Alrighty. This is what we're thinking about. Am I going to do this? Am I really going to do this? See if it's going to work. Uh-uh. Hey folks, it's T2sday. It's halfway through 2025, which is pretty hard to believe. 6 months gone, 6 months ahead. And the goals for today was to have a plan for the second half of the year confirmed and have a lot more big fun. I am going to call those both check marks. There's little asterisks on how it all works out, but I'll talk about both of them. So we've got the development process, that is to say, our simulated full self-driving vehicle, BV, the latest developments there, and then planning for the rest of the year. Let's check in first with BV. Hey, BV, said Slim. I heard him complaining about your driving up in the cafeteria. I thought nobody was here but us, said BB. Yeah, nobody's getting paid since democracy fell, said Slim, but the junior devs are just kind of hanging around. So what were they saying, said BB, like I care. They were saying your coords are wrong and they don't cover the whole grid and they're not even the same each time you hit the grid. Well, what am I supposed to do, said BB. Drive all the way up to the red and freak out? How does that help? Well, said Slim, what if you had a switch to flip so you wouldn't care about red? No way, said BV. What if somebody messed with the switch? No, I trust my guts, thank you very much. It was just like a brain surgery, said Slim, so you wouldn't, have to see the red. Wait a minute, said BV. Look what I can do. Ha ha ha, said Slim, you look funny. Yeah, okay, said BV. But get this, I can hardly see anything in front of me with my eyes like this. Oh, said Slim, so maybe you could go to the edge. Let's try it, said BB. So that's BV. we resolved some of the problems that BB was having, in particular with BB's cross-eyed approach to the void, to the red edge. It can, and pretty reliably, pretty repeatably, get the same coordinate system all the way around. That required a whole bunch of cleaning up of when increments happened and so on and so forth. But it's working a lot better. But the overall approach is still very fragile. And, it reminds me of a 3D printer. If you have a 3D printer, when you first start it up and it's beginning to do a print, it calibrates, right? It goes all the way to the end of the x-axis and all the way to the end of the y-axis and all the way to the end of the z-axis to find out where the origin really is so that it can get everything all laid out. And that's what BV's doing. Go east, go south, go west, go north. And that's great as long as nothing ever changes and nothing goes wrong and BV never slips and a ball doesn't drop on BV and knock them off and so on. And beyond that, all of that localization was only meant to be the first step of a more sophisticated, subtle, and sort of information-rich kind of world model. But that's tough to do at this point, and it leads to the next point, which is the second half pivot for the T2 tile project. And there's this repeating pattern of research that because we're using a cellular automata that scales indefinitely, so it takes up space, and the bigger it is, the more space it takes. And there's a speed of light, in effect, how fast information can move across this thing. And that means when a construction on a cellular automata gets bigger, anything that involves the entire thing gets slower because it takes longer for information to get all the way across whatever the thing is as it grows. And the result of this is, from my point of view, is that just when things start to get interesting, like when the Diamond Replicator 2 years ago, which we see in the waiting room at the beginning of each live stream, we got a Diamond Replicator going that really didn't have a whole lot of cheats in it. It was pretty damn pure in a lot of ways. But as a result, when I tried to do multicellularity, it was taking absolutely forever to get to the frontier, to get to something to try and see if it's new. The same thing is happening with BV here, that the calibration that we were just seeing a whole bunch of them, that takes over a day of wall clock time to do it once. So when everything was right except it was screwing up in the north, that was like a day to get a data point on that. So the constructs run too slowly to keep developing further, and that's been the frustration. And so, the computing team creed, first be robust, be there, show up, have an answer, then try to make the answer right, and then as efficient as necessary, we deliberately push efficiency to an as-needed third position, which is where robustness usually goes. But now we're going to embrace it for this next step. Second half 2025, as efficient as necessary. So the idea is to take the lessons learned and over, since 2012, 2016, all the stuff with ULAM and MFM, the techniques, the ideas, the HC3, the axons, the growth, all of that stuff, and find hardware to run it on that supports this MIMD, multiple instructions, multiple data, because we want to have lots of events happening literally simultaneously, and the events are of different types of atoms that run different code. So everybody tells me you should be using GPUs, and it's like, thank you. The problem is GPUs want to be doing the same thing all over the place, and what we want for the movable feast is to be able to do different things all over the place. And so we'll find some of that hardware, and we'll just explore what we can do as long as we insist on going fast. So let's see how the rest of it played out, that we had the little coming up teaser at the beginning. Oh, thanks a lot. 1.7 million yen. Hokkaido. Who picked Japan? All right, so I'm going to stop this right here because I wanted to try calling Amex first. Yes, main menu, operator, representative. Sorry, so you're saying when I actually try to make the charge, American Express may try to get in touch with me? Okay, and I was trying to avoid that by calling you right now. Okay, I would like to opt out, unsubscribe to all product marketing. I didn't catch your name. Lou, Lou. Okay, hi Lou, thanks. You have a nice day. So that's it. So the idea is, is am I gonna do this? Am I really gonna do this? So what we're saying in 10 to 12 weeks, we are gonna have found a place for this, found a 20 amp dedicated circuit for it, and we will try to explore how much we can use this power, this 480 cores, to do events, to do event processing. But the big elephant in the room, or the tiny mouse in the room, is the fact that each core, each T2sday core, only has 1.5 meg of static RAM. But at least from the point of view of hardware, 1.5 megabytes of RAM per parallel distributed core, they think that's generous. They think that's a ton. I think it's microscopic, but it's the first one that I thought maybe I could work with it. Am I going to do this? I'm old. Have I mentioned to be starting on a new adventure like this? But Southwest furthers. What do you say? Shall we do it? See if it's going to work. Order. All right. It is done. It is done. So there it is. We are going to have, hopefully, in 10 to 12 weeks, again, assuming TENS torrent doesn't ship early or be incredibly delayed, which seems more likely to me, they are shipping the black hole boards, the cards. They are shipping individual cards now. People are starting to get them and do little stand-up reviews on YouTube and so on and so forth. But the actual quiet boxes with all the liquid cool and because I don't want to deal with any of that. I want something that has the greatest chance of getting working quickly so that I can, as quickly as possible, move to software level issues and not mess around with hardware ones. The goals for next time, get BV running on the T2 matrix, and, release Ulam 6. There's been a ton of development that's happened on Ulam over the last couple of years, that's all been sort of technically called Ulam 5 or 5.1, 5.2. It's time to wrap all that stuff up and get it out. Plan the box for the quiet box. That's what it's called, the TENS torrent quiet box, because it's liquid cooled, and so on, and have more big fun. So I am nervous about starting to work on the quiet box, starting to work on the black hole cards, but also excited, just to see how much stuff I can get him to do like that. It's all wide open. I have no idea about what the best design is going to be or what anything is going to be. I'm hoping that maybe I could make it a little bit more, have a little more interactive setup stuff, maybe some kind of Twitch or whatever kind of thing like that, but we'll see. that's what's coming up in the second half of 2025. Thank you so much for checking in whenever you stop to take a look at this, and I hope to see you next time. Alrighty. And that is stayed on 15 minutes, so hopefully not too bad, because I had a lot of canned content there. Why don't we check in and see what's up with the chats? Alrighty. Forgot to tell BB that its eyes might get stuck like that. Yeah. And clearly that's what BV's mom would have been saying to BV if BV had a mom. Unfortunately, we really don't know where the hell the researchers and main developers are in BV's lab at this point. So anyway, Ploticus, is Ploticus an actual thing? I don't know who Ploticus is. And I mean, well, anyway. Thanks all. We'll see. Everybody on the Discord, the Tens Torrent Discord, which I've been kind of lurking on for a couple of weeks now, several weeks maybe. They keep saying that the little baby RISC-V cores, of which there are zillions of them in the Tens Torrent architecture, are so simple that you shouldn't be thinking you can really program them. You shouldn't be thinking you're going to be doing complex control logic and stuff like that. But that's exactly what I am thinking I'm going to do. And I'm hoping that what they're thinking is that, they want to do machine learning, so they want bandwidth to slam billions, literally, of little dinky floating point numbers in and out of the cores and do matrix multipliers on them and move them back out again as quickly as they can. And at that point, trying to do any little slow logic in the cores themselves would just be, throwing away their bandwidth, their compute intensity. Whereas I'm not thinking that way. To me, it looks like each one of those little cores, except for only having a meg and a half of RAM, looks like a little T2 tile. They're running at a gigahertz. The T2 tiles top out at a gigahertz. They'll clock down to 600 megahertz if they need to, because they overheat, but like that. So there's hundreds and hundreds of them that are connected by a really fast network, really, really fast on chip, the NOC, the network on chip. But then, gigabit Ethernet or 100 gigabit Ethernet between the cards, like that, so that the quiet box, black hole quiet box, is coming with 4 black hole cards in it. So it's 120 of these Tensix cores, and each Tensix core has 5 baby RISC-Vs on it, like that. And so they get to 480 because it's 120 times 4 cards. We shall see. But it's interesting, and I've spent some time trying to imagine, is there some way I could use some of the incredible, because these in addition to these little baby cores that take up hardly any of the area of the whole chip, there are big matrix multipliers and vector products, all that kind of stuff that takes up much more space, because again, it's officially aimed at machine learning workloads, where it's matrix multiply or die, and I keep wondering if I'll be able to find a way to use the matrix multipliers in some effective way. I don't know. We'll see. But that's coming, and all right. So I guess I will call it. Yeah. Yeah. And thanks, folks, for stopping in, especially for stopping in live. And I will see you in July, and before then, I will see you in the Discord, hopefully. or see you on the Fediverse, and step by step. All right, so I guess I will call it. And where do I stop the stream? Don't cross the streams. Okay, so that's it.